Good morning, students. So, in this unit, there are two sections. One is on Fourier series, another one is on Fourier transforms. So, we have finished Fourier series. Now, we have come to the second section, which is nothing but Fourier transforms. Under Fourier transforms, we are going to learn Fourier integral theorem. So, Fourier integral theorem, Fourier sine and cosine transforms, Fourier transform of single pulse, trigonometric and exponential and Gaussian functions, inverse Fourier transform and convolution theorem. So these are the topics that we are going to cover under this section. So first let us learn on Fourier transform. The Fourier transform is a type of mathematical transform from one domain to another domain. The Fourier transform transforms a non-periodic function f of t in time domain into a function corresponding frequency domain. So frequency domain to time domain to frequency domain. It's a tool to break a function into sinusoidal forms characterized by sine and cosine terms. So we are going to break into sine and cosine terms. To understand the conduction of heat, these are the applications: heat, wave propagation, digital signal processes, image processing, filtering, and all those things. There will be applications. There are applications for the Fourier transform. Some other applications are also there for the Fourier transform, which is nothing but signal analysis, sound filtering, partial differential equations, image processing, conduction of heat, and wave propagation. To learn Fourier transform, Fourier integrals, we need to have two formulae. One is f of s equal to 1 divided by 2 pi. You have to learn by heart. Minus into plus infinity f of x e power I s x dx. So this is s into x. For the inverse Fourier transform, x into s. So here s is here x is here. Here x is here it is s. So x into s into x. Okay, this is like time domain to frequency domain to time domain. So you have to learn these two formulae for Fourier integrals and Fourier transform. And of course, these are the identities that we have to learn, complex identities. E power I theta equal to cos theta plus sin theta, e power minus I theta equal to cos theta minus I sin theta. Adding these two will give you this, subtracting these two will give you this. Okay, when you are going to add these two, this one will be cancelled. You have to cos theta. When you are going to subtract, you will get this. So we are going often this one will appear. Now we will solve some problems. You will learn what is Fourier transform. So this is a Fourier transform of a rectangular pulse. See here, we have a rectangular pulse. There exists a signal between minus t by 2 and t by 2. This is nothing but a. Else it is 0. Here it is 0. There is no signal. Here it is 0 because there is no signal. Here alone there is a signal. See here. So this is called a rectangular pulse. And in the y-axis we have g of t, and the x-axis we have t. So g of t is given as a. So this will be your a between this limit minus t by 2 and t by 2. 0 elsewhere. So the formula is g of omega equal to g of t e power minus I omega t dt. So instead of g of t, you have to substitute a. So a e power minus I omega t dt between the limits minus t by 2 to plus t by 2. Just integrate, pull a out. You have pulled a out. Integrating, that will give you e power minus I omega t divided by minus I omega t by 2 minus t by 2, upper limit and lower limit. So you can substitute the upper limit first. So first you will substitute upper limit. So e power minus I omega t by 2, you have minus e power, you have to substitute the lower limit. Already it is minus t by 2. One minus is there. So it has become plus. So plus I omega t by 2. Is it okay? Divided by minus I omega. So I have interchanged, remove the minus sign. I remove the minus sign. I have written interchange. I have interchanged these two terms. Okay. Now, I have written the same thing here. Here also I have written the same thing. Now we know that omega t equal to 2 pi. Omega equal to 2 pi by t. So omega t equal to 2 pi. So instead of omega t, we will have to substitute 2 pi. 2 will get cancelled. We have e power I pi. Correct? Similarly, here also omega t is nothing but 2 pi, and you have e minus e power minus I pi. And of course, multiply and divide, and this will give you. So what we can do is So this becomes, and there's a mistake. It's no. What I have done is, instead of omega, you can substitute 2 pi by the t. Instead of omega in the denominator, we can substitute 2 pi by the t. So 2 pi is here, 2 is here, pi is here. T I have brought it to the numerator. So 8 divided by pi times this one. And we know that e power I pi minus e power minus I pi is divided by 2 pi is nothing but sin pi, according to this formula which on the first slide. See, according to this formula. So we have now sin pi. So 80 by pi sin pi. So 80 times sin pi by pi. The graph for sin pi by pi is nothing but this. So this is your sine curve. See, this is your sine curve with a larger amplitude which exists only at the origin. So when omega tends to 0, only this will have a more impact, more significant. See, omega tends to 0. Elsewhere it's a diode. So this is sine pi, but pi is nothing but this graph. So this is the answer. This is where Fourier integral, Fourier transform from time domain to frequency domain. So we started with the time domain. See here, time domain. We ended with frequency domain, g of omega. Frequency domain, which is nothing but AT sin pi by pi. We started with rectangular pulse. The Fourier transform of rectangular pulse is nothing but sine. See, the Fourier transform of this one will be this. What is the inverse Fourier transform of this? That will be this. Is it okay? So Fourier transform of rectangular pulse will be your sine curve. The inverse Fourier transform of sine curve will be your rectangular pulse. So this is the answer. This is the answer. Sketch the following wave function in time domain and calculate it by using Fourier transform. Okay. So we have now S lies between -2 and +2. We have 3. So we have 3. So this is what 3. Elsewhere it is 0. Here it is 0. Here it is 0. Below -2 it is 0. Above +2 it is 0. Here alone it is 3. Okay. So your f of x, the Fourier transform will be f of x equal to minus into plus infinity f of s e power minus isx ds. Okay. And instead of f of s, you can write 3 here. So 3 e power minus isx ds. So on integration, that will give you 3 times e power minus isx divided by minus ix with the limits 2 to -2. Now I have removed the minus sign and I have interchanged the limits. See, I have removed the minus sign. I have interchanged the limits. So now substituting the upper limit will give you 3 times 3 divided by ix. We have substituting the upper limit will give you, already one minus is there. So minus minus plus will give you e power ix2 minus, substituting the lower limit will give you e power minus ix2. Correct? Substituting the lower limit will give you e power minus ix2. Now multiply and divide by 2. Multiply and divide by 2. That will give you 6 by x. Here you have 2i. I have brought this I here. So this becomes 2i. What is this one? This is your sin 2x. So 6 by x times sin 2x. Now we started with the fs. We ended with the f of x. Earlier in the problem we started with the f of t and ended with the f of omega. We started with the f of s. Ended with f of x. So s domain to x domain, or from x domain to s domain. So that is called the Fourier transform. Find the Fourier transform of f of x equal to 0 in this interval x less than a and 1 x lies between a and b, and 0 x is greater than b. So this is schematically it has been drawn. See here, this is schematic. 0, here it is 0. X less than a. X is greater than b, again it is 0. In between a and b, and what is the answer? 1. So between x lies between a and b, answer is 1. Okay. Now we are going to find out the Fourier transform. F of x is given by 1 divided by root 2 pi minus plus infinity f of x e power isx dx. So your Fourier transform f of x is given by this formula, minus infinity to plus infinity, minus into plus infinity. It lies between 3 units, this unit and this unit and this unit. We will have minus infinity to a to b, b to infinity. See here, minus infinity to a to b, then b to infinity. So we have separately we have written. Now between this limit this is 0, here also it is 0, in between we have 1. So this is 0, in this limit this is 0, this becomes 1. So f of x is nothing but 1. So e power isx dx, this is again does become 0, so 0 here. So we have only this term alone. So 1 divided by 2 pi root 2 pi e power isx, after integration that will give you is. So substituting the upper limit will give you e power isb, substituting the lower limit will give you minus e power isa divided by is. Is it okay? Now, so Fourier transform of f of x is nothing but this is the answer. So this is the required Fourier transform of the function. Is it okay? Now find the Fourier transform of f of x equal to x mod x. So far it has been given as simply x, but here it is given as mod x less than a. So x can be either plus or minus. In the earlier case, x itself will be x, whereas in this case your mod x is there. Mod x means either you can write minus x or plus x. Is it okay? So minus x less than a, plus x also less than a. That's the trick is given, but we will solve. And 0, x is mod x is greater than a. Now you just remember, as I said just now, x is less than a or minus x is less than a. Correct? Mod x means either x or minus x. So x less than a or minus x less than a. If minus x is less than a, we can write, remove the minus sign, x is greater than minus a. Correct? X is greater than minus a. Correct? So now minus a is less than x. Correct? Minus a is, this is both are the same. So minus a is less than x. I have written as it is, x less than a here. You combine these two, x lies between, x is minus a and plus a. You combine these two, here it is x less than a, here it is minus is less than x. So we combine these two, that implies that x lies between minus a and plus a. Is it okay? Similarly, mod x is greater than a. If mod x is greater than a, one possibility is x is greater than a. Another possibility is minus x is greater than a. So I can interchange. I can interchange and write x is less than minus a. Okay. Combining these two, that will give me the same thing. So here combining these two, that will give me 0. So here x lies between minus a and plus a will be 0. X lies between minus a and plus a will be x. So I have rewritten the limits here, and I have drawn the same thing in the graph. Minus infinity to 0, x lies between minus a and plus a, that will be your x, and here it is x is greater than a, again it is 0. So on either side 0, we have x alone exists in this limit. Okay. So if any problem there exists, any problem you have to change into exactly like this. This is very important. So now easy to solve. Fourier transform of f of x equal to 1 by root 2 pi minus into plus infinity f of x e power isx dx equal to f of s. So Fourier transform of f of x equal to f of s. It implies that Fourier transform of f of x equal to f of s. So now we have 3 limits. See here we have 3 limits. So we can write into 3 limits. Minus into minus a to plus a to infinity. So 1 divided by root 2 pi. This becomes 0 and this also is 0. So you have to only solve only this one. See here, you have to solve only in this interval. So we have f of x e power isx dx. This alone exists. Instead of f of x, you have to substitute x. So x e power isx dx. Now you have to solve this one. We have to use only Bernoulli's formula. We know Bernoulli's formula, ub dx equal to ub1 minus u prime b2 plus u double prime b3, where u1 for differentiation, v1 for integration. So you have to remember. So using this Bernoulli's formula, we have 1 divided by root 2 pi Okay, what is u? U is nothing but your x. What is v1? You have to, as I said, you have to integrate this term. This is your v. This is your u. So you have to integrate. Integration will give you e power isx divided by is. One minus is there. So minus is there. You have to differentiate x. That will give you 1. You will have to integrate this. So this is v1. You have to integrate. So v1 becomes e power isx divided by r d v of is. One more is. And you have one more is will give you I squared minus 1. One minus is there plus. So this becomes plus a squared. See, this becomes plus a squared. And this is as it is like this. Now you have to substitute the upper limit. Wherever you find x, you have to substitute the upper limit. Wherever you find x, you have to substitute the lower limit. So this becomes substituting the upper limit will give you, this is your earlier, the last point in the slide. So wherever you find x, you have to substitute a. So a e power isa divided by is. Substituting the upper limit will give you e power isa divided by a square. Now you have to substitute the lower limit. Our minus is that. Okay, substitute the lower limit minus a. Instead of x, you have to substitute minus a. See, minus a. E power isa divided by is. Now substitute the lower limit will give you minus a. Already minus is there. So e power plus isa. See, plus isa. So substituting the lower limit will give you e power minus isa. See, e power minus isa divided by a square. Okay. Now this time I have written the same thing here. I have written the same here. And minus minus plus a e power isa divided by is, and minus plus minus e power isa divided by s square. I have pulled s square common. I have pulled is term. Here you have is term. Here you also we have is term. Here you have s square term. So 1 by s square a divided by is term. So that will give you this, and this will give you this. Now e power isa plus e power minus is nothing but 2 cos sa, and this is nothing but your 2i sin sa. Okay, multiply and divide by I. Multiply and divide by I will give you I square. A is there. I square is minus 1. So minus A divided by S. 2 cos SA plus 1 by S square 2I sin SA. So I have written the same thing here. Okay, now I have pulled 2 out. 2I out. Here 1I is here. Here also we have 2I. So 2I out. So 2I divided by root 2 pi. The remaining term sin SA, and I have written minus as cos SA. Is it okay? Now multiply and divide by 2, root 2. You just multiply and divide by root 2. So root 2 divided by root 2. Root 2 and root 2 will be 2. This 2 and this 2 will get cancelled. So we have root 2. Already one root pi is there. So put together I can write root 2 divided by pi. And I is here. The same thing is here. This is for f of s. Fourier transform of this one. This one is your f of s, which is nothing but this. Okay. Now we'll find out, we'll go for some other problem. Find the Fourier transform of f of x equal to a squared minus x squared in this limit mod x less than a and 0 x is mod x is greater than a. Of course, we'll have to change the limit. As we have seen in the previous problem, we'll have to change the limit mod x. I change that to ordinary x. Okay, this limit will become x lies between minus a and plus a. And of course, this limit becomes x is less than minus a or x is greater than a. Okay, so we have a squared minus x squared in this interval, and in the elsewhere it is 0. Now, as usual, we will have to find out the Fourier transform of f of x, which is nothing but f of s. Fourier transform, it is asked Fourier transform. Fourier transform of f of x is nothing but f of s. So f of s equal to 1 by root 2 pi minus into plus infinity f of x e power isx dx. So we have now 3 limits. X is less than minus a, x is greater than a, x lies between minus a and plus a. We have 3 limits. We have 3 limits. Separately we can write. This is 0, and this becomes a squared minus x squared. See here f of x is nothing but a squared minus x squared. So this is 0, and f of x is nothing but a squared minus x squared. Now integration of minus a to plus a squared minus x squared times e power isx. You have to use, for the integration you have to use Bernoulli's formula. So this is your u and this is your v. Bernoulli's formula. So Bernoulli's formula goes like this. So this is your u. This is your v1. v1 is integration of this. So e power isx divided by is minus. You have to integrate. You have to differentiate this. So differentiate will give you minus 2x. You have to integrate this. That becomes v2. So e power isx divided by is multiplied by is, which is nothing but this one. E power is multiplied by is multiplied by is will give you minus s squared. So we have e power is divided by s squared. Okay. And again we have to, so we have minus 2x. So we have to do once again. So that becomes minus 2. So this becomes minus 2. Okay. So we have to integrate again. So that will give me e power isx divided by s squared multiplied by is. So that will be the next term. So this is your u v1. This will be your u double prime v2, and this will be your u triple prime v3. Okay. After that we will get 0. Now substituting the upper limit a here. Substituting the upper limit. So that will give you a squared. This becomes a squared minus a squared is 0. Substituting the lower limit also will become 0. Because x is there. Instead of x you have to substitute a. Instead of x you have to substitute a. A squared minus a squared 0. Substituting the lower limit. Lower limit is minus a whole square plus a square. Already minus is there. So a squared minus a squared. So substituting the upper limit and lower limit will give you 0 here. So this term will go off. We have only next term. Next term is minus minus plus 2x. Okay. So 2x e power isx divided by s squared. And this term we have one minus is there. So we have now minus 2 e power isx divided by is cube between the limits. Now we just substitute the upper limit. So that will give me, instead of x you have to substitute the upper limit a. Okay, 2a. So 2a by s squared e power isa. Substitute lower limit will give you e power minus isa. Okay. Now here too we have 2 by is cube. We have e power isa minus e power minus isa. Okay. We have substituted now. Now this can be replaced with 2 cos a. This can be replaced by 2i sin a. We can pull 2 out. 2. We can pull 2 out. So this becomes 2 divided by root 2 pi. Here you have a. I multiply and divide by, I am going to multiply and divide by s. Because this is s cube is there. So I am going to multiply and divide by s. So that will give me as divided by s cube. So I can commonly write. So that becomes as cos sa minus sin sa divided by s cube times 4 divided by root 2 pi. This is your Fourier transform of the original signal. So we started with f of x, we ended with f of s. So Fourier transform by f of x is nothing but f of x, which is the answer. So now let us solve some other problem. F of x equal to 1 in this interval and 0 elsewhere. 0 in this interval. 0 in this. But we are going to evaluate these two. We have to find out the Fourier transform and we are going to evaluate these two. Let us try. So first we will go with the Fourier transform. And the Fourier transform by f of x is nothing but f of s, which is nothing but 1 divided by root 2 pi minus into plus infinity f of x e power isx dx. And already we know that we have changed the interval. We know already the techniques how to change the interval. So in this interval, x lies between minus a and plus a. Here it is x less than minus a, x is greater than a, this is 0. So minus into plus, minus into minus a, this is 0. Minus a to plus a, f of x is nothing but 1. And a to infinity, again it is 0. So here it is 0, here also 0, this term, second term alone exists. So we have now 1 by root 2 pi minus a to plus a, f of x, instead of f of x we have to substitute 1. So e power isx dx. E power isx you can expand it like cos x plus I sin x dx. Easy to integrate. See, separately you can integrate, easy to integrate. But this is, this is even function, this is odd function. See, this is odd function, sinus odd function. This is even function. For the even function, you can write 2 times. For the even function, odd function, minus a to plus a, answer is 0. So this term will not appear. This becomes 0. And for the even function, instead of minus a to plus a, we can write 2 times 0 to a. So it becomes 2 divided by root 2 pi 0 to a cos sx dx. And for the integration, the answer is sin sx divided by s. Substituting the upper limit will give you sin sa divided by s. Instead of x, you are going to substitute a. Sin 0 is 0. So you have f of s equal to 2 divided by root 2 pi sin sa by s. So this is the Fourier transform of f of x, which is nothing but f of s. This is the required Fourier transform of the function. So now the Fourier inverse transform. We have not we have calculated only the Fourier transform of the function, and we are going to evaluate these two. This is the next one, next section. We have done the Fourier transform of the function. We have found out f of s, and to find out the section 2, we know that f of x, you just go with the inverse Fourier transform. So f of x equal to 1 divided by 2 pi minus into plus infinity f of s e power isx ds. So we can write this one as it is. F of s, already we have found out f of s. You substitute here e power isx as it is like this, and we have the limits between 1 and 0. We have limit for the first limit is mod x is less than or equal to a, and 0 mod x is greater than a. Okay. Now, so we can write 2 divided by 2 pi. If x equal to 0, we can write this. You can pull out. We can pull this can be written as 2 divided by root 2 pi. That will give you 2 pi minus into plus infinity sin sa by s ds, which is equal to 1. Now these two will cancel. This pi goes to the right hand side. That will give me integration of minus into plus infinity sin sa by s ds equal to pi. This is odd function or even function? Even function or odd function? This is odd function. This is odd function. Odd by odd. Even function. This is even function. Suppose s is not there. That is odd function. Is it okay? So sin sa by s, it is an even function. Even function you can write 0 to 2 times 0 to infinity. So 0 to infinity with 2 times. So 2 sin sa by s ds equal to pi. This is for pi. I can bring this to here. So 0 to infinity sin sa by ds equal to pi by 2. So this is what asked in the problem. See, this is what asked. Evaluate 0 to infinity sin s by s ds. This is what is asked. See here. Answer is pi by 2. Then for the next one, again use inverse transform. F of x equal to 1 divided by root 2 pi minus into plus infinity f of s e power minus isx dx. So instead of f of s, you substitute this one. This one multiplied this one will give you 2 pi. So 2 divided by 2 pi. As usual, 2 divided by 2 pi. Sin sa by s. So instead of e power isx, I am going to expand. Cos sx minus I sin x. Multiply this term. So that will give you this multiplied by this multiplied by this in this interval. Okay. Now comparing both the sides. You have to compare real number with real number, imaginary number with imaginary number. See, real number with real number. This is imaginary term. So imaginary term, there is no imaginary term here. So 0. Only we are going to compare the real term. So this becomes 1 by 5 sin as cos sx divided by s, which is equal to 1. You compare the real term. Pi multiplied 1 will give you pi. This is what asked. See in the problem, see here. In the problem, this is what asked. Integration of 0 to minus into plus infinity sin as cos sx by s. See here. This is what we have calculated. Minus into plus infinity sin as cos sx by s ds equal to. So this is what asked. We'll stop today. We will see in the next class. Bye students.